Hello guys, welcome to today's video. In today's video, we are going to see about a topic electrostatics, and in that we'll be seeing Coulomb's law. And in this problem, we'll be applying Coulomb's law to solve this problem. And let's begin. So the question is very simple. Two charges plus q and minus q are separated by a distance r. Okay, there are two charges. One contains a positive charge plus q, and another contains a negative charge minus q. Now the question is, what will happen to the force? Obviously, when there are two charges and these are unlike charges, a force of attraction is present in between them. So the question is, what will happen? Let's say from a charge plus q, right? Now remove 75% of the charge plus q from plus q. Then what it means is you are going to remove 75% of plus q and transfer it to the charge minus q. Okay. Now, so after removing 75 percentage of the charge from plus q and transferring it to the charge minus q, what will happen to the force between the two charges? Okay, this is what is the question. Now we head on to the solution of the problem. So when we take 100% from 100 percentage of q, when we take 75%, it is easy to say 25 percent of plus q remains. Okay, so when you remove the positive charge from the initial charge distribution is 100%, now it is reduced to 25%. Now you are going to transfer this to 100 percentage of minus q. Now remember, we have to see that it is minus q. Okay, and this is plus q. So when you transfer plus q to minus q, the magnitude of minus q decreases. Okay, so when you transfer 75 percentage of plus q to 100 percentage of minus q, what remains is minus 100 plus 75. So minus 25%, 0.25 q remains. Okay, or it is minus 25 percentage of minus q. Okay, final distribution is 0.25 k of 0.25 plus q and minus 0.25 minus q. This is the final charge distribution. So now we'll be seeing the actual solution of the problem. So the final distribution is minus 25 percentage of minus q and plus 25 percentage of plus q. Now we have to find out what is the change in the force happening when in the reverse. We have to find the force acting in this reverse distribution. So we have reversed this distribution from the initial distribution, and now we have to find what happens to the force between them. So when we apply the Coulomb's formula, 1 by 4 pi epsilon naught plus q into minus q by r square. Okay. Now we know that 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. Okay, so now we substitute, instead of plus q we substitute plus 0.25 q, and instead of minus q we are going to substitute minus 0.25 q. So this is because of the transfer of 75 percentage of plus q to minus q. Okay, so when we do the calculation, we get 1 by 4 pi epsilon naught into plus 0.25 q into minus 0.25 q by r square. So when you do the calculation, it's 0.0625 into 1 by 4 pi epsilon naught plus q into minus q by r square. Okay, so the initial configuration is plus q into minus q by r square into 1 by 4 pi epsilon naught. So the answer can also be written as 0.0625 into 1 by 4 pi epsilon naught plus q into minus q by r square, which is equal to 0.0625 into f initial. Instead of plus q into minus q by r square into 1 by 4 pi epsilon naught, we have substituted as f initial. Okay, so the final answer is 0.0625 into f initial, or if you are going to write in terms of fractions, you can write it as 1 by 16 into f initial. 1 by 16 is 0.0625. Okay, so if you do the calculation, you'll be knowing it. Okay, so this is the final answer. So when we transfer 0.75 or 75 percentage of plus q to 100 percentage of minus q, the force between them is reduced by 1 by 16. This is the final answer. So I have also attached practice questions for you. It will be of immense help if you will be doing this practice question. So that's all, guys. We'll be meeting in a next video. Hope you enjoy the session.